Right, good afternoon everybody. My name is Rob Walpole, and a bit about myself. I've been working with XML technologies since about 2005, and I've been working with semantic web technologies since about 2008. And today I'm going to be talking a bit about knowledge graphs, a bit about personal knowledge graphs, my interest in personal knowledge graphs, which is to do with journaling. I'll explain that a bit more. I'll talk about how you might be able to create a personal knowledge graph, and a little bit about genealogical data, which can go into that knowledge graph. I'll explain how. And I'm going to talk about RML, which is the RDF mapping language, and YARML, which is a YAML version of RML, which makes life a bit easier. And then I'll talk a little bit about what this might lead to in the future, what possibilities it opens up. So knowledge graphs, I imagine pretty much everyone here knows roughly what a knowledge graph is. Perhaps the most commonly known one is the Google knowledge graph. So if you search for a term about which there are a lot of documents on the web, you'll probably see a box like this one, where Google have amalgamated some data from different sources, usually Wikipedia, probably a website from the place itself. Another knowledge graph, very well known one of course, is DBpedia, which is the knowledge base behind Wikipedia. Another one which is quite well known, Wikidata. Quite a nice one because that's one that it's very easy to edit yourself. If you haven't done so, I recommend having a go at that. But what do we mean by a personal knowledge graph? Okay, that's a good question. It's quite a new concept. I recommend this book. I think it's the first book that's been written about personal knowledge graphs. It's a collection of essays, really, but there's some really good information in there. And in the book, they identify three types of knowledge graph. So there's the open knowledge graph, or the OKG, which is the kind of thing we've been talking about, Google, Wikipedia, DBpedia, Wikidata. Then there is the enterprise knowledge graph. So these are quite often closed knowledge graphs, or linked closed data, you might say, which are used by businesses such as IKEA, Airbnb, BMW. There are lots of other examples. In fact, there's now an enterprise knowledge graph foundation. And then the third type of knowledge graph they identify as the personal knowledge graph. But what is that exactly? So one definition from Ruben Verbera is it's all data that you yourself create combined with all data that others create about you. It's quite a general definition. Here's a slightly more specific one. A personal knowledge graph is a knowledge graph where a single individual, called the owner of the PKG, has full read and write access to the knowledge graph and the exclusive right to grant others read and write access to any specified part of the knowledge graph. The primary purpose of the PKG is to support the delivery of services that are customized particularly to its owner. Okay, so there isn't exactly an agreement what a personal knowledge graph is at the moment. It's definitely a work in progress. When I'm talking about personal knowledge graphs, what do I mean? Well, I see it as a knowledge graph with me at the center of the knowledge graph, and everything links out for me. So it links to people, places, and things that are important to me. My knowledge graph is linked closed data, so it's linked data, it's written in the linked data using all the standards of linked data, except that it's closed, it's not open linked data, so it's private. But I believe it also has the possibility of sharing, selective sharing of information within a personal knowledge graph with other people, and I'll talk a bit more about how that might happen as well. So my personal interest in, personal knowledge graphs and knowledge graphs in general is to do with journaling. So my family seems to have a history of writing journals. I keep a journal on and off, have been doing for many years. I think I got it from my mum. She was also a keen journaler, and my father as well. So I've spent quite a lot of time looking at journals, trying to find things in journals, and this is a little snippet from one of my mum's journals. just to give you an idea of the kind of thing that you might find in journals. I mean, journals are very personal things, but there is a tendency to find certain things I've noticed over and over again. So this is what I would describe as a 2D traditional journal entry. It's a piece of text, and if you're lucky, it might have been written on a computer. More likely, it's been written on a bit of paper and it's disappeared somewhere. So what are the benefits of linking a journal to a knowledge graph? One of the key things it gives you is the ability to disambiguate terms. So when I've been through my dad's journal, he's talked about things. He served in the Navy at one time, and he was on a ship called the Birmingham. And he talks about Birmingham, and he says, Birmingham this, Birmingham that. And if I didn't know my dad, I wouldn't know that he was talking about a ship. How do I know he's not talking about the city, Birmingham? So this allows you potentially to disambiguate that kind of thing. It also potentially gives you a better way to search for things. If you're searching for an entity in the text, then that's going to be easier to find. The act of linking a journal to a knowledge graph quite often brings more meaning. So if you you're writing something, you go somewhere, Paris, whatever, and then you link it to DBpedia or something like that, you'll probably read a little bit, and maybe you'll learn something you didn't know, so you get some new meaning. It also makes it easier at a later date. So journals, people tend to keep them for years, chuck them in a cupboard, forget about them, and then they go back to them, and what was I talking about? I don't even know what I was talking about. But if that journal had been linked to entities, resources, in a knowledge graph, it might be a bit more meaningful. And also in future, if you keep a journal and put entities in, link it to a knowledge graph, then potentially you might be able to access an AI-based personal assistant. We all know now that AIs work better if they have access to structured data, such as XML, or to RDF data. It tends to give less hallucinations and more accurate results. So if we go back to my mum's journal entry, and we'll just talk about what we find, what kind of things I said we might find in there. So you tend to find things that are public and notable, that kind of meet the Wikipedia notability criteria. So there's lots of documents about, lots of people talk about. So that could be a city that you're visiting, or a movie that you've watched. And then you'll find things that they're not personal things, but they're kind of a bit more localized. So you might talk about a community group you're involved with, or a restaurant that you go to locally, something like that. But you're not going to find that in Wikipedia. And then there are things that are really only kind of notable to me. So people and places like my grandfather or my grandfather's house. I mean, that's meaningful to me. It doesn't really mean anything to anybody else. So, so looking at those three categories. So the first category, as I said, probably DBpedia, you'll find something in there. Let's say a local restaurant. You're probably not going to find that in DBpedia, but there's nothing to stop you creating an entry in Wikidata for that. And I've done that myself a few times. But my grandfather, well, he's not going to be anywhere other than where I put him. So personal knowledge graph is potentially somewhere I might want to do that. So if we go back to this journal entry again, and just have a look and see. So we've got some things that I would say we're going to find in DBpedia or Wikipedia. So we've got London, Barnet, which is a suburb of London. We'll find lots of information about that. Taj Mahal. Okay, well, I know that that's not the Taj Mahal. That's a restaurant. So I'm not going to look for that on DBpedia, but maybe I could create an entry in Wikidata if there isn't one already. But then there's all these people. So this, got to remember, this is my mum talking. So she's talking about her mother and her dad. That's my sister. That's my dad. That's my dad's aunt and my dad's uncle. So there are all these people that are being talked about, but they ain't anywhere on the web. You're not going to find those in any existing knowledge graph. Okay, so let's say I decide to create a personal knowledge graph and put these people into it so that I can reference them from my journal. So how might I do that? Well, I could take a very naive approach and just start creating some RDF. So here we go. I'll create a resource for myself, and I'll say I'm a FOF person, and I've got a given name and last name. Great, so far so good. Okay, so yeah, I'm going to add my parents, So I'm going to create a resource for my mum and my dad, and my sister and my brother. And then I'm going to, oh, of course, my sister's married, so I need to create an entry for my brother-in-law. And maybe they've got kids, so yeah, I need an entry for my niece and nephew. And suddenly I've got my work cut out. I've got to create all these RDF there, and I haven't really got time. This is something I do in my spare time. I haven't got time to do this, so forget about it. So maybe there's an easier way to do it, though. So that's why I started looking at genealogical data. So genealogical data, there is a data, there's a data format for that, which is called GEDCOM, stands for Genealogical Data Communication. It's a de facto standard for genealogical data, maintained by Family Search, which is a non-profit organization. Okay, so here we've got the Waltons, which I'll use as an example. Obviously, I don't want to talk about my own family, so we're going to use the Waltons. If you came to the demo jam last night, you'll have seen them before. So I went into, I used Ancestry. There are lots of different places where you can create family trees quite easily with a nice GUI. So you're not worrying about creating RDF or XML. You can do it all using a nice GUI. And then most of them will allow you to download that in a GEDCOM format. GEDCOM 5.51 is the kind of industry standard for genealogical data. It's, there's also a GEDCOM X, which is it's not a newer standard than GEDCOM 5. It's a different format. So it allows, so it gives you the option of getting the same data in JSON. And more interestingly for us, it also allows you to get the data in XML format. So you can also export relationships. So this is a relationship of the type couple. So you have, it's a symmetrical relationship, so you have two people who are in a relationship. You have parent-child, so in this case the parent is the first person and the child is the second one. So how do we turn this into linked data? Okay, so this is where RML and YARML come in. So the RDF mapping language, RML, is an unofficial draft specification, but it's an extension of R2 RML, which is a W3C recommendation since about 2012. And it's R2 RML is for, if you're not familiar with it, for extracting RDF from relational databases. But RML is a generic mapping language, so it adds on top of the ability to extract from relational databases, ability to extract RDF from CSV, ability to extract from JSON files using JSON path, which a few other people have talked about in this conference. And from our point of view, most interestingly, RDF from XML using XPath. So YARML, you've got to say this in a pirate voice, YARML. So YARML is a human-friendly text-based representation of RML rules. And that's quite important because when you looked, and if you saw my demo jam last night, the RML I wrote was about 70-odd lines, and that transformed into over 500 lines, I think it was, of RML. So it's much easier to write YARML than RML. So it's a subset of YAML. A few other people have talked about that, so it's a human-friendly representation. So this is an example of a YARML mapping file. So we start with declaring some prefixes that we want to use. I'm going to use FOF. Actually, that's a typo. That top one should be FOF. And I'm going to use the waltonsexample.org as my base URI for the Waltons people. And then if we look at this in the mappings here, so I'm creating a mappings for people, which uses a Waltons XML file as a source. And the little squiggle XPath means I want to use XPath. I could use JSON path there if I wanted to. And my XPath statement, which is A mapping for a person is from the XML file, so the root element is gedcomx, and a person is what I want to refer to as one of my people. So then the next two parts, the subjects, so this is where it turns it into RDF. So you've got the subjects, which is the RDF subject. So I'm using my prefix of Walton's example person, and I'm taking the attribute ID from the person, and that will then become my URI for that person. And then my predicate objects, so it's just the predicate is the A, which stands for RDF type, if you're familiar with that, and FOF person. So I'm saying that this is a FOF person. So if I use that, if I transform that, that's what I should end up with, a URI, a triple, basically. So I can do more XPath. So let's say I want to use the given name. So from the context of the person, the name form part, this is just the XML structure of the gedcomx. I take the given name, that's an abbreviation I've used there, it's actually got a full URI in front of it. And I take the attribute value and map that to a FOF given name, so that gives me a FOF given name of John. And I can do the same for last name, so you can start to see I'm starting to build up some RDF here. So there's John Boy. And in addition to the basic functionality of XPath, you also have access to grel functions. Grel functions are from the Open Refine framework. And basically what you can do here is in your predicate objects, you can say instead of an XPath, you want to use a function. And then you pass in the parameters, and you say what you want to get back, which in this case is an IRA. This is a very simple function. All I'm doing is replacing, it's a string replacement. Happens that they put a hash in front of the ID, which I don't want, so I'm removing the hash and replacing it with nothing. So there's lots of possibility to manipulate the data using functions. The RML parser, so once you've written your YARML mapping file, you can parse that into RML using the RML parser, which is just a JavaScript command line interface, and that will generate, so calling the parser, passing the input is the YARML file, and I want to create an RML output file in turtle format. And you can actually do this online. Again, I showed that in the demo jam last night. There is an online tool you can use for this as well. And then the final step in the process is to take the, so you can use the RML mapper. The RML mapper is a Java library provided by Family Search, and you can use that to generate your linked data from your RML rules. So in this case, it's just a Java command line, and I'm passing in the mapping file, the rules TTL, and the output is going to be the Walton's TTL. And you might be saying, oh, where's the input file? Well, the input file, if you remember, is actually encoded in the rules file. So that's already baked in there. And that will give you some RDF. So you can see here that, so first person here is John Boy Walton. And we've got some parents identified. They could actually be on the same line, but so we've got this one here. And if we look at that ID, we'll see that that is John Walton Sr. And the other one is Olivia Walton, his mum. And we can also see that Olivia Walton has a spouse, which is, of course, John Walton Sr., and a child, which is John Walton. So we can easily create lots of RDF in that way. So, conclusions of this piece of work. Well, first of all, I would say it's possible to build a substantial personal knowledge graph quite quickly in this way. When I ran this across my own family tree, which fortunately my mum put together some years ago, so lots of detail in there, it created over 5,000 triples, which would have taken me months to do on my own by hand. There's also the possibility to export, so it's quite a limited amount of data that I've shown being exported there. There's actually potential to add a lot more data to the GEDCOM, so through whatever tool you use to create the GEDCOM, you can often add things like residence, employment. There's lots more information you can add in there, so there's the potential to extract that and turn that into RDF. There's also the possibility of adding information to your personal knowledge graph from other sources using the same technology. So basically, if you can get hold of data, you know, it could be text message data, could be email data, whatever. If you can get hold of that in XML format or JSON format, you can write YARML, which will enable you to turn that into RDF, and you could then add that to your personal knowledge graph. So it's a nice, easy way to do that. And of course, the open world assumption that you have with linked data means that, you know, once I've extracted all this information in GEDCOM format and turned it into a knowledge graph, I can add more information. I can add whatever properties and links I want to add into those resources. So where do I see this going in the future? Well, obviously there's a number of steps I had to go through to achieve this. I had to use a command line interface, I had to use a mapper, I had to do there was also a step to transform the GEDCOM 5 into XML. So these things could be chained together in a workflow. I could use something like Apache Hop to do that. And that would mean that I could create this data essentially at the click of a button. So if I can do it for myself, I could do it for other people as well. There's also, once you've got this personal knowledge graph, so what I'm interested in doing is being able to link that information into the journal. And I've got a number of different ideas about how I could do that. But one possibility, of course, is named entity recognition using a tool such as DBpedia Spotlight, which will locate named entities in your text and link them to the correct resource. And the other thing that I've been looking into, as I mentioned earlier on, is the idea of being able to share this information. So if I extract my family data and create that and turn that into a personal knowledge graph, well, I might want to share some of that with other members of my family, for example, because we share the same grandparents. So it would be nice that they wouldn't have to do the same thing, that I could actually share that. And to solve that problem, what I've been looking into is using Solid, which is the project initiated by Sir Tim Berners-Lee. And yeah, the idea is that you can actually potentially provide very granular access to resources, but we're not quite at the stage of being able to demo that yet. So maybe that's sometime in the future. Thank you very much.
Thank you. Thank you very much. Maybe you have a few time for a question. Okay, you're first.
I was planning to ask a question that said you haven't said anything about it, and then it appeared in the last line of your futures slide. I did a fair bit of work with genealogical data and GEDCOM, and people still sometimes download my GEDCOM to XML converter. The interesting trend to me with that kind of data has been moving away from personal databases to linking with other people's personal databases. And it's sort of, the pendulum has swung to having a global database of everyone's genealogical data. And to me, the big problem is genealogical data tends to be 95% accurate. and when you link it all together, the inaccuracies multiply, and you get the whole issue that people aren't maintaining provenance, and when you discover an error, you can't propagate the correction, and things like that. So I wonder if you've sort of given any thought to the whole area of inaccuracy of data, which is intrinsic to this kind of data. And incidentally, it's not just genealogical data. I hit the same problem. I did work with a project that was doing criminological databases, which are a lot less than 95% accurate, and where correcting errors is incredibly important. But this linking without totally integrating and losing the origin is a subject that very much interests me.
Right. So, so my perspective on that is that I'm creating a personal knowledge graph. So it's very personal to me. So I'm creating something that I want to use, and my default position on that is that it's local to me. It's probably offline. It's probably not. You know, it is currently offline. It's not something I'm currently sharing with anybody else. So it's more like, I see it as more like a personal notebook or diary. So I'm responsible for maintaining the data in there. So yes, when I come to share it, absolutely, I can see potential for conflict or disagreement about information, but the things are very personal to me. So I might see something differently. I might see something about my grandfather which is different to how my sister looks at my grandfather. So I guess my position on that is I think it's okay to have that, because this is my, you know, and if she disagrees with me, that's up to her. Yeah, so I guess that's my take on it. But in terms of quality of data, yes, absolutely. So I believe in defining a data model for these things. So my personal knowledge graph would have a data model. And once I have decided what properties I want to use and what triples I want to create, then I would create shackle shapes, or I would define those in some way so that I can say, I've extracted this data. Does it meet my personal quality requirements? But yeah, that's what I'd say.
Yes.
I've also built a very small prototype personal knowledge graphs because I saw some other academics doing it in the RDF world. When I listened now to you, I found it interesting. I was just wondering, it would be great, I would like to know what you think about it, if you have a personal knowledge graph with your basic data, which everyone constantly needs, the banks, insurances, every time you do a contract, and you could somehow push on a button and push it to them so you don't have to fill out forms anymore, you don't need appointments. I think that would be a great use case. Or what do you think about it?
Yes, thank you. I agree. That's a slightly different use case. I mean, I see exactly what you're saying. How this would integrate with that, I'm not sure. I guess I see a personal knowledge graph as a whole bunch of stuff. It's genealogical data is one thing that might be in it, but absolutely, I would potentially keep my personal address information in there, and I agree with you that I might choose to share that with organizations. That's why I'm very interested in the solid ideas, because that gives me the potential of me. I own my data, so I own my address data, and I share that with organizations. And if I move house and I don't want them to see where I'm living anymore, then I don't show them my new address. I just, so I control my data. That's the idea. Yeah.
Okay, one last question.
Robert, you know that I've done a lot of work in this area as well. And what I thought maybe I missed it, but I didn't get how. So you've got the data that's there for you to link to, but it didn't seem to solve your original problem, and it is a problem, of the time-consuming exercise of going through the text in your journal and actually making that link to your knowledge graph even. Did I miss it? I mean, did you do that, or is that another future?
Okay, so what I've done up to this point is I've spent quite a bit of time going through actually my dad's journal and working out what's in it. What do people write in a journal? which is why I came to the three kind of key things, the very general things, the slightly more specific things, and the very personal things. And that's what I found over and over and over again. So yeah, that was a huge amount of work, looking at that and working out what was in there. But that's not what I would be interested in doing. Is as I write a journal, that as I'm writing it, I link things as I go. So yeah, it's really, this is building something for the future. Is really, yeah.
Okay, thank you very much again. And now we have a